Metric equations. Does everybody find this on the front of their packet? Okay. So it says worksheet 13AB. That's from the chapter 7 packet. The learning targets are to be able to graph in parametric equations and identify the endpoints, to be able to rewrite them into what's called rectangular form. In other words, they don't have a T anymore, and use projectile motion equations, okay? On the reference sheet that you should have got on your desk today, the pink half sheet, the equations for projectile motion are given. I think below the unit circle. Does it say that below the unit circle? Yeah, I'm pretty sure that's where I put it. So if we get that far today, we will need those. All right, parametric equations are a brand new concept for you guys. It has to do with taking 3 variables, okay? But we're not graphing 3-dimensionally. We're talking about, for example, this is a population of wolves compared to years and rabbits compared to years, okay? So year 0, there's a few wolves and a lot of rabbits. Then they both start to grow and then decay. As the more wolves there are, the less rabbits there are, okay? So the idea is that you can take, these are both in terms of years, and you could instead graph them with the number of rabbits and the number of wolves, eliminating the years and just looking at the fact that it's a cycle. As one grows, the other goes down, okay? It's a cycle, so the number of wolves changes the number of rabbits. It says, so far you've learned to represent the graph of a curve in an XY coordinate plane in a single equation involving 2 variables, X and Y. We're going to now talk about different models and aspects. So when we had a distance versus time, like you threw up the ball and it came down, right? The shape was not actually making a parabola, but as time went by, the vertical distance up and down changed. We could also graph the horizontal distance away from us as a function of time. But what we're going to do eventually is combine the vertical and horizontal distance. For example, when something is thrown or shot at an angle, okay, so you shoot a basketball towards the basket, you don't throw it straight up, right? Okay, so we've talked about vertical, like -16 t squared plus velocity of 0 time. Okay, so we've talked about those things, but those are all thrown straight up or down. Today we're going to finally get to more real world problems where you're talking about something that has a velocity with an angle. All right. Yes. Sure. So from the parametric equations, you can now determine where the object was at any given time. So if you know time 1, you can determine both its horizontal and vertical distance away. The variable t is called a parameter. If we use the restrictions here of t is between 0 and 4, so the first 4 seconds of its path, the curve follows an orientation because it starts here and then as time progresses it's going this way. So orientation just means you're putting these arrows on the graph to show which direction it's going. And it's going to show up on your calculator in an order as well. All right, so parametrics are used to describe horizontal and vertical components of an equation. Parameters are arbitrary values, usually time or angle measurement. So the parameter is which values of t they want you to use, and they will state, I will always state that in the question, or you may have to restrict it based on the situation. For example, if we're talking about shooting the basketball, you can't have negative time, right? And it's going to be a very short time, but that's realistic. time 0 until time 3, when it hits the floor, that's all the time we can talk about. All right. If a curve, oh, this is the definition. It says if f and g are continuous functions of t on the interval, then the set of ordered pairs, f of t, g of t. So we are not actually graphing t. We're going to put the values into the equations and come up with an x and a y. All right, so this sounds really confusing. Let me show you a quick little example, and then we'll do one together. It says here that x is going to be defined as t squared plus 5, and y is going to be defined as t divided by 2 plus 4. And it says use the values from -4 to 4. Now, that does not mean only integers, but we generally just plot the integers because it's easier. But it's all values from -4 to 4. It's a continuous curve. So in my little table here, I put -4 all the way to +4 for the t. Okay, then what I do is I put each of those t values into this equation and come up with the x's. Then I put each of the t values into this equation and come up with the y's, and then what I actually plot are the x's versus the y's. And this one started here at 21.2, and then it started to curve around, and at 0 it was at 5.4 here, and then it went back the other way. So that's why these arrows are doing this. Now, what do you notice about this? Is this a function? It is the first time we've been able to graph something that is not a function on our calculator. Okay? It is not a function. It fails the vertical line test. Yes, Tristan, this is for you. All right, so let's try this together. It says, notice they are not always functions, okay? So this is a big deal, and students will not follow this, but it says right here that you are only to use values of t from -3 to +4. You don't have to use every value necessarily, and you definitely aren't going to use necessarily all the decimals in between there. But I put down the for this one, I put all the integers from -3 to 4, just so we had a lot of points to plot. Now, the equation given for x is -3 plus 4t. So don't worry about y yet. Let's just put -3 into this equation and see what we get. -3 plus 4 times -3 would be what? Let's just call this 4t minus 3. Would that be easier? It's the same thing, right? So 4 times -2 would be -8 minus 3 is -11. Anybody put a -1 in? What do you get out? Okay, 0 minus 3 would be -3. Put in a 1, we'd have 4 minus 3 is 1. What do I get if I put in a 2, guys? 8 minus 3 is 5. 12 minus 3 is 9. 16 minus 3 is 13. Okay. Now we go back, and it tells us the y equation is t squared plus 3. We are putting in the t values, guys. Don't look at those x's. Okay? So we're supposed to square this and add 3. Remember, when you square a number, if you use your calculator, you need parentheses. It should be positive. So 9 plus 3 would be 12. 4 plus 3 would be 1 plus 3. And then it's going to start back again. And 4 squared would be 16 plus 3 would be 19. Did I do anything wrong? Somebody double checking me? Okay. The endpoints, this is actually going to have endpoints because t was restricted from here to here. So the endpoints are when t equals 3 and when t equals 4. So what are the x, y ordered pairs we got at the endpoints? Anybody know? okay? So when t was -3, we got this endpoint, and when t was +4, it ended here at 1319. Now, what we're going to do on our graph paper is plot the x's and y's. We don't plot t. We plot the function of t in terms of x and y. So we have, it's not a function though necessarily, -15 and +12. Oh my goodness, this is tiny. All right, I hope you can do better than I do. -11, +7. -7, +4. Yeah. -3, 3. +1, 4. 5, 7. 9, 12, and 13, 19. All right. This one did turn out to be a function. Okay. Some important things. I had endpoints again. And how did I find those endpoints? They occurred at the ends of the t range that we were given, right? All right. And what am I missing on my graph? Did anybody catch what I'm supposed to do? Orientation. Remember what that meant? Put the arrows on. Which way did it go? As we went from -3 to +4, our curve was going this way, yes? And I don't care how many arrows you put on there, but there could be a possibility that it would graph in the other direction as we went from -3 to 4, the graph, and it could have been doing something crazy like this, okay? But you need to just put whatever, as you went down this list, whatever order your curve graphed in, okay? Anybody else have a question? Yes, your calculator is going to eventually do this for you, okay? The problem is the calculator doesn't stop at the endpoints necessarily. All right, the second thing we have to do is to rewrite these without the t. So this is an example, it's not the one we just did, but it says x is -3t and y is t squared plus 2. Do you remember substitution, guys? Okay, well, we're going to solve this for t, and then we're going to put it into this one so that we don't have a t anymore in this, and we have an xy equation. So if I made this one t equals x over -3, and then I plugged that into this one, it would say y equals x over -3 squared plus 2, which would be y equals x squared. You square this, you get 9, okay? Or, because it's in the denominator, 1/9 plus 2. So this would graph as a parabola that's opening up. Making sense? All right, let's try the one that you have. It says when you're eliminating a parameter to convert to regular, you can solve either of the parametric equations first. So what they're saying is I could have solved this one for t, but anybody know why I didn't choose that one? How would you get t by itself here? What would you need? A square root, and then you got to remember the plus or minus, right? So it gets tricky if you solve that one. That's why I didn't choose that one. All right, you have this one on your paper. It's mostly done for us, it looks like. It says x equals 4t minus 2 and y equals t squared plus 1. So we want to get the t by itself over here. So added 2 and divided by 4, and we got this. And then it says to plug that in here. And so I would be okay if you left it like this on the quiz, okay? if we were moving this around a little bit, I would still leave the x plus 2 quantity squared. But what's 4 squared in the denominator? 16. Because it's in the denominator, though, it would be like a 1/16 out here. The only reason I'm rewriting it this way, does anybody remember what this is called? That's vertex form of a parabola. So the parabola would have its vertex at -2, 1. Everybody with me? But I'm okay if you leave it like this on the quiz, okay? I will be fine. Any questions? Now go back and let's try the first one. So this is the very first equation that we just graphed a minute ago on that teeny tiny little graph paper. What is the idea we need to do here? Yes, isolate t here and then substitute it in. So I have x equals -3 plus 4t. How do I isolate t there? Add 3 and then just put it all over 4. And then I take that one and I plug it into the y equation for the t. So now that I will have only y's and x's. Now, it would be okay with me if you left it like that. If you squared, I'm going to leave the top x plus 3 quantity squared. But if you squared the 4 in the denominator, it would be a 16, but because it's in the denominator, it would be 1/16. I only rewrite this because now you can tell the vertex is at -3, 3, and it's a parabola that's opening up. Is that what we got when we graphed it, guys? Was the vertex we got right here at -3, 3, and it was opening up? Okay. And the 1/16 actually made it wide. But like I said, I would be okay if you just left it here. Yes. So that one, that's a great question. I'm going to show you how to type it in with the t. Okay? You can type it in here, but then it's not really using parametrics because we've already eliminated the t. All right. I'm okay with us doing this one on the calculator, but can you just tell me real quick what you would set up if I asked you to do it by hand? Because there is one on the quiz where I asked you to fill it in. You could use your calculator, but the table's there. What would the table have, guys? This is really important because it's going to determine what we put in the calculator in a minute. What are the values of t that we're supposed to be using? Okay, this is really important because you're going to have to tell the calculator that you only want to graph from -4 to 4. Now, that's a lot of values, okay? Then what are we supposed to do to all those values to find the x? Right. So let me see if I can do this real fast. 16 plus 4 would be 20. 9 plus 4 would be 13. 8. 5, 4, 5, 4 plus, yes, and 13 and 20. Yeah, you can't even read that. All right, what are you supposed to do to find the y's? These aren't going to be pretty because you're supposed to do what? Yeah, divide by 2 and then subtract 3. So -4 divided by 2 would be -2 minus 3 would be -5. All right, the next ones are going to be decimals. Let's just find the end point. What would the other end point be? 4 divided by 2 is 2, minus 3 is -1. So the end points were at 20, -5, and 20, -1. I'm just going to do a couple of the even ones in here. If you had done -2, you would get out a -4. If you put in 0, you'd get out a -3. If you put in 2, you'd get out a -2. The rest are decimals. We can do it on the calculator in a minute. But what do we actually plot one more time? Yes, so 20, -5, and it's counting by ones. It's just that every other one is labeled. So there's 20, -5. And then eventually ends up at 8, -4. There's one value in between there, but we had a 4, -3. Is that one 8, -2, guys? So it's curved back around this way. And then 20, -1. So it's going to be a sideways parabola, and it's going which way? From the bottom, it's going this way. All right, I'll fill the rest in when we graph it on the calculator, but ready to try this? Okay, I need everybody doing this. Everybody got a calculator? Anybody need to get up and get one? Alexa, you have a calculator? Okay, everybody, I can't see. So everybody got one? Need more time? Okay, so what you want to do is you want to go to this mode button. Okay, and you want to be in degrees. We're going to need that in a minute. It's really not important for this question at all, but eventually we're going to need to be in degrees. So while we're here, let's put it in degrees. And then go down, and you don't want function anymore. For the first time, we're going to arrow to the right. In the coming weeks, next couple weeks, we're going to learn to use all of these: parametric, polar, and sequential. But today we're using parametric. Everybody good? Okay, so make sure you're in parametric. All right, then you're just going to hit clear. Now, before I go any further, this button right here, does everybody see it has X and then T and then theta and then N? And you've never figured out why all that garbage is on there. Each one has to do with the mode. When it's in function mode, you get an X with that key. What's in parametric mode, you're going to get the T. When it's in polar mode, you get the theta, and sequential mode, you get the N. Okay? So right now, if you hit the Y equals key, I need you to make sure that none of your plots are on. Everybody's plots off up there? Make sure you don't have any dark boxes up there from taking the quiz last week or something that you've turned a plot on, because that will mess up everything. Okay, now, do you see that it's got this weirdness? It says equation X, number 1, in terms of T. Y in terms of T. And then it goes on to the next one, X2, X3, X4. Okay, we're going to put in, for this problem that we're doing, for the X, T squared plus 4. Everybody good? X equals T squared plus 4. So we went to Y equals, and now we're just using T squared plus 4. And you should be getting the T from this button, not anywhere else. Everybody get it? And then we're going to T divided by 2 minus 3 for Y. T divided by 2 minus 3. You could put parentheses in if you wanted, but it'll always divide before it subtracts, so we'll be good. Everybody got those typed in? Okay, this is the part students don't get, and they mess up on the quiz. You can only do this correctly and find the endpoints if you go to, Window, and you tell it what T values to use. The T values are given in the question. We are supposed to use -4 to 4. So we're going to put the T min as -4 and the T max as +4. Now, the T step, everybody gets all confused. I don't get the T step. It's what do you want it to count by as it goes, because it's the only way the calculator knows to do this is to actually put the numbers in, just like we did. So on our little table, we used, we counted by ones, right? So we could put 1 in there. You can put something smaller, okay? You could go 0.1. Generally, I just use 0.1 on all of them for the t-step. And I'll show you in a minute what happens, okay? Now, my window is not going to work. What was the graph paper given? Because that helps usually. -4 to 25 or something going across. I'm going to go, okay, I'm going to go -5 to 25, but you can do -4 to 20 if you want. And the scale it counts by ones. The Y graph paper went from like what, -6 or 8 or something, up to +3 or 4. I'm going to go -8 to 4, I guess, by ones. Okay, now I'm going to graph it. Okay, did anybody see it, or did it go too fast that you didn't see it? The direction it was graphing in. Okay, the other thing is, does anybody remember the bouncing ball? We can turn on, if you go back to y equals and you arrow all the way to the left, yeah, I'm not comfortable with these calculators, but here where it says line, yeah, I don't want dotted, but I do want, is it offer me the chance to put, here, if you get the little -0 looking thing, yeah, it does go slower, but you can see it graph as it goes. Mine doesn't go super slow, but maybe yours does. Did everybody see it as it graphed a little bit slower that time? Yes. I'm going to take a little commercial break here to show you guys what this T-step thing does. If I change the T-step to 1, you won't notice a huge difference, except that it flew by really fast because it only calculated 8 values or whatever it was, okay? But it looks pretty much the same. If you were to change the T-step to like 4, let me show you what happens. It only puts in 3 points, and so, okay, because it only calculated -4, 0, and 4. So that's what it connected. That's why I say if you put in 0.1 all the time, it will give you a nice smooth curve because it's calculating 10 values for each integer, okay? If you put in something, don't try this, please, but if you put in something really, really, really tiny, well, I don't care if you try it, but you may. Was mine too small? It didn't like it? What is it? X max is greater than X min. Am I putting it in the wrong spot? -4 to 4. Okay, it's calculating 100 values every time it has to go to the next integer. Okay? Does everybody, you can hit on at any time, guys. This is a huge issue that students don't know. You can hit on at any time to tell your calculator to stop. When it's stuck and it seems like it won't do something, just hit on. Okay, so can we all agree that 0.1 is what we're going to leave for the T-step?
Yeah.
Okay. All right. Now, if you go to the table, second table, here's the values for X and for Y to fill in your little chart if you had to on a quiz. Does anybody notice, though, what happens? Did it only go from -4 to 4? Yours probably isn't counting by 0.2s anyway. Okay, let me go back to my table set here. Tell it 0 and 1. I don't know why it was going up by some crazy amount. Okay, so it doesn't stop. It doesn't stop at the endpoints. You have to know to stop, okay? The table is not going to stop. The graph stopped, though. if you go back to the graph and you trace, it gives you the first endpoint. And then if you trace, you can, this is interesting, guys. I want the little cursor to go to the left, but the only thing my arrows will let me do is go forward in t values. The only thing I'm allowed to adjust is the t value. If you go second trace, I can't do anything except calculate the t value. Okay, I can put in t equals 3 and it'll jump there, but I can't do anything else. I can't figure out where the x and y are. All right. Any questions? So I'm going to make this a nice smooth curve and move on. Oh, except we should probably practice eliminating t. Okay, how could we eliminate t on this one? Yes, that would be a great plan. So let's make y say, what do you want to do to get the t by itself? Oh, we could, yes. If we multiply through by a 2, it'll change that to a -6 though, right? And then we're going to add it over there. Now, some of you would have probably said, I'm going to add that first. And then I'm going to multiply by 2. And you could have left it like this. I don't care. Okay, same thing. Now, what are we going to do over here, though? Yeah, we're supposed to square all this. So would be x equals, yeah, it would be easier if you used 2y plus 6. Or if you had done it the other way, you would have had to put extra parentheses. Because the whole thing is squared plus 4. Okay. But do you notice it has x equals in terms of y squared? That's a sideways parabola, right? Okay. Actually, you don't have to do this on a quiz, but if I subtracted the 4 over here, I'd have y plus 3 squared. If I squared that 2 out front, I'd have a 4. Then I could divide this. OMG, on the quiz. This is not the form off your reference sheet. We had to get rid of the 4 over there because I squared it. Okay. How do I move that 4 to the other side and get 1/4, right? I got -4s. I got crazy business. Like, I don't know how to do algebra anymore. Okay, but that's the form of this parabola that's going sideways that we're used to, okay? But I'm not going to make you do that. I just wanted to show you that it is related to what we've been doing. Okay, so try this one on your calculator. Everybody try it on your own. What's the important thing besides retyping what defines x and y? You want to, where do you put this into your calculator? Where do you put that in though? Yes. And your T min is going to be 0, and your T max is going to be 9, and your T step is going to be 0.1. Square root of T, and then make sure the +2 is not underneath there, right? It's got an arrow to the right so that's not under the box. And then my window needs to be 0 to 9. Graph paper? I think we're probably okay with what we have. I don't think we need it that big, but. Oh, mine went off the top. Did yours go off the top? What's it supposed to be? Oh, okay. Yeah, I need to change my graph paper, or my window to better represent the graph paper. I'm going to just go out to like 10 here, I think. And what does the graph paper look like? Yeah, I'm just going to make them both -5 to 10. Does that look like what it's doing? Okay, so it's just a little piece of a parabola this time. How are we going to find the endpoints? Yep, we can go trace, and one is at 0, 2. If you trace out to 9, where t is 9, you'll find the other one. I have 4.55. Or you could go to the table. Remember, they were supposed to go from 0 to 9. So you could at 0 put down 0, 2, and at 9 it's 4.55. They're not nice in between, right? There's very few of them that are nice. So for graphing it on our graph paper, we have 0, 2 is nice. And then 0.53. And then the next nice one is 2, 4. And then 4.5, 5, 2, 4.5, 5. But is that enough to give us, since we had a graph on the calculator anyway, so give us the right shape, right? Yes, thank you. The orientation went this way. Just means it started on the left and went to the right. So we had 0, 2 as an endpoint and 4.55 as an endpoint. Questions? Okay, anybody want to eliminate t this time? Okay. So how would we get the t by itself here? So we'd have 2x equals t, and then what? Move that over here, so we'd have y equals square root of 2x plus 2. So actually, this is a square root graph, which is still part of a parabola, but it's not got any values down here because you can't square root negative numbers and so on. Okay. Here's a couple more to practice, eliminating the t. Is this going to have a squared? It doesn't matter. Oh, it says y equals here, doesn't it? For both of these. So that means we need to get this t by itself and substitute it into this one. What would this say? -3 equals 2t, and then we divide by 2. Yep. And then it says put it over here, so we'd have x minus 3 all over 2 with a -4 on the back. I'm okay with you just leaving it like that. Okay. If you simplified it, let's see, that would be x over 2 minus 5.5 or some fraction. Yep. Yeah. Oh, yeah. Yeah, you could. I don't care. All right. It doesn't have a squared, so it's not as big a deal. Okay, over here, x minus 5 equals t. So if I just plug that over here, I'd have -3 and then quantity squared, but this would be an x minus 5. So describe that graph for me. This first, no, without looking. The first one would just be a line because there's no squared. What's the second one going to be? Parabola that opens down. Okay. I want to see if we can get to one of these questions. At least let me type one in. I don't think we're going to get there. All right. So projectile motion we'll leave for tomorrow. It's going to be kind of a long lesson tomorrow then, but it's fun. So tonight, your homework is page 469, but it's in your packet. Which page is it on? 15A? And which ones can you get through here? Through 13? Does that seem right? These are the two you won't know how to do yet. Okay. Everybody good?